All right, guys, so we're going to go over the practice problems that were from week 1. I will make sure I go through them in their entirety, and then if you need to make corrections, you can go ahead and do so. So here we have number 1. I believe I did this one to start on the other video, but we're going to go ahead and start from the beginning and go over it. So number 1, Natasha walked from the library to the grocery store and then to her house. So she went from the library to the grocery store, then to her house. So notice I drew a picture there. The diagram shows the top view of the locations of these three places and their distances from each other. Which measurement is closest to the shortest distance in miles from Natasha's house to the library? So what we're going to do is we're just going to use our Pythagorean theorem. We are going to label our sides A, B, and C. And remember, C is always the hypotenuse, which is opposite the 90-degree angle. So let's go ahead and make a list of our required variables. A equals B equals C equals. And remember, our formula is A squared plus B squared equals C squared. And then we're going to plug into the formula. So I chose this side right here, the library to the grocery store, as side A, simply because it was the first leg of her trip. It does not matter which one's A and which one's B, so long as you are consistent and never choose the hypotenuse as either A or B. And then 0.9 is my B, so 0.9. And then we get C squared is unknown. C is unknown. So now we're going to substitute into the formula. 1.7 squared plus 0.9 squared equals x squared. All right, so now we're just going to run these numbers through our calculator because I honestly do not want to do them in my head. So let's pull up the calculator. Okay, so now even though most of you do not have access to this particular type of calculator at home, unless you're using the emulators, I'm going to use the emulator simply because it's the one that shows up best on the screen. All right, so our numbers were 1.7. So I'm going to go 1.7, and we want to square that, and we get 2.89. And then we are going to take 0.9 and square that, and we are going to get 0.81. And then we're going to add those two numbers together, 2.89 plus 0.81, and we're going to get 3.7. So let's go ahead and fill those into our formula. Okay, so we have 2.89 plus 0.81 equals x squared, so 3.70 equals x squared, and then we're going to take the square root of both sides. So let's go ahead and do that in our calculator. Okay, so the square root of 3.7 is 1.92. All right, and we can look at our answers here and see that the closest to 1.92 is 1.9. Okay. All right, so now it says a right triangle and two of its side lengths are shown in the diagram. And so let's go ahead. It wants us to find which measure is closest to the value of x in centimeters. X is one of our legs because it is not the hypotenuse. So whenever you see a right triangle and it's asking you for a side length and it's only giving you side lengths, find hypotenuse and label it. Always label it C or label it hypotenuse. Every time you see a right triangle, label the hypotenuse. Every time. All right, so then we have which measurement is closest. So we need to label our other two sides, A and B. I'm just going to label the longer side B in this case, even though it doesn't really matter. You'll remember in the previous problem, I labeled the shorter side B. Does not matter which one's A, which one's B, so long as C is the hypotenuse. Never forget that. So A was 12 and B was unknown, and the hypotenuse was 39. Our formula is A squared plus B squared equals C squared. And then we plug in our numbers. So we get 12 squared plus x squared equals 39 squared. 12 squared is 144. That is one of the perfect squares that you should know. X squared is just x squared. And 39 squared, I actually do not know off the top of my head, but I know it's less than 1600. All right, so it appears that 39 squared is 1521. All right, so now the equation reads 144 minus x squared equals 1521. So we're going to subtract 144 from both sides, and 144 minus 144 is 0. Bring down the x squared, and that is going to equal 1,377, and then we're going to take the square root of that number. So square root of 1,377 is equal to 37.108. And our answer choices do include an answer that says 37.1. So A is our answer. All right, number 3 says the dimensions of a regular piece of paper are 8.5 inches and 11 inches. Veronica folded the piece of paper along its diagonal. Which measurement is closest to the length of the diagonal in inches? When you're talking about a rectangle, or usually even with a square, depending on how you arrange it, but when you're talking about a rectangle or a square, the diagonal is going to be the hypotenuse of the triangle that you form. Okay, so if we have a sheet of regular paper that is 11 inches by 8.5 inches, and we fold it along the diagonal, we're going to have a right triangle with side lengths 8.5 and 11, and the diagonal is unknown. Now remember what I said just a few moments ago, label your hypotenuse, always. Always label your hypotenuse. First thing, label the hypotenuse. What should you? Yeah, label the hypotenuse. Please, just label the hypotenuse. All right, so we're going to do a squared plus b squared equals c squared. And I am going to label the 8.5 side A. So A is equal to 8.5, B is equal to 11, and C is unknown. All right, so A squared plus B squared equals C squared. So then we have 8.5 squared plus 11 squared equals C squared. I don't happen to know off the top of my head what 8.5 squared is, but I do know that 11 squared is 121. But let's just go ahead and rely on our trusty calculator, which apparently is 72.25. And then we're going to add that to our 121 to get 193.25. So what I have now is 193.25 equals c squared, and I'm going to take the square root of both sides, and that will give me my x, because my x was my c. I should have been plugging that in everywhere. All right, and when we run that through the calculator, it looks like we get 13.9014. And when we round that to the nearest tenth, we get 13.9 inches, and I only picked the nearest tenth because that was the closest answer that was given to us. All right, so now we're going to move on to lesson 2, the 45, 45, 90 special right triangles. One thing I did see a lot of people say that they were happy they could use Pythagorean theorem on this, and you can. But the thing is, it's faster if you know the shortcuts, okay? Just try to learn the relationships because it will help you when you're doing your more advanced trigonometry. So it's really important that you can learn these shortcuts. Okay, so in number 1, it says in the right triangle below, line segment AB is 10 and angles B and C are congruent. Now remember, if two angles are congruent in a triangle, that means the sides opposite to them are also congruent. So this is an isosceles right triangle, which means by default it is a 45, 45, 90. Because if you have the interior angles of a triangle equal to 180, and 90 of those are taken up by the right angle, and the other two are equal, you would divide it by 2 and get 45. All right, and it says that AB is 10. What that also means is that AC is 10. Now, many of you would like to see this done both ways. I am going to do both the table and the Pythagorean theorem. I will do the table first, simply because we went through a lot of questions with Pythagorean theorem. So, for the table option, remember we are labeling our shorter sides A and our hypotenuse is going to be a times the square root of 2. All right, so remember we make our tic-tac-toe table, and we're going to put our side lengths, our angles. Angles first. 45, 45, 90, and that's going to equal a equal a square root 2. All right, so our side lengths are a, and they are both equal to 10. And if we're just going to plug 10 into for a, because a equals 10, and the hypotenuse is a square root of 2. So I'm going to plug 10 in for a. So hypotenuse is 10, which was a, square root of 2. And that's all you have to do to find the hypotenuse. A common error would be to do the 20 square root of 2 because 10 plus 10 is 20, but we're not adding, we're simply writing proportions. Now, if you want to see a Pythagorean theorem, both my sides A and my sides B are the same, so we're going to go ahead and A equals 10, B equals 10, C is equal to some unknown ratio number in this case. So we have our A squared plus B squared equals C squared. Now, notice how none of your answer choices here were decimals. So that is one other sign that shows you should be using the ratios and the relationships because it's quicker. What we're going to end up with when we do this Pythagorean theorem style is some extra work. So I hope everyone's ready for that. So we have 10 squared plus 10 squared equals unknown value squared. All right, so 10 squared, as we all know, is 100. And we're not going to go crazy by doing it twice. 100 plus 100 is 200. And then we have to take the square root. And so we need to figure out what x is equal to. Now, if you're really, really, really good at simplifying radicals, this won't take long. But to simplify the radical, remember we take 200 and we're going to factor it. 1 and 200, 2 and 100. I know my perfect square, so I'm going to stop here. So the square root of 200 is equal to the square root of 100 times the square root of 2. Square root of 100 is 10. Square root of 2 is 2. Or square root of 2 is square root of 2. So 10 square root 2. So we're going to go ahead and do the next one. Okay, so we have number 2. What is the length of line segment BC, which is right here, in triangle ABC? This one is actually quite simple, remembering that if A is a 45-degree angle and B is a 90-degree angle, then C must also be a 45-degree angle because interior angles of a triangle are 180 minus 90 gives me 90, which is that angle right there, so B, and minus 45, which is A, gives me 45, which is C. So we know these are two identical angles. Remember, in any triangle with congruent angles, the side lengths opposite are also congruent. So if AB is 4 centimeters, BC is also 4 centimeters. Make sure you pay attention. All right, so in the next one it says, in the right triangle below, the length of line segment AC is 30. All right, AC is also my hypotenuse and my side length C if I'm going to be doing the Pythagorean theorem. Okay, so I'm going to try and find the lengths of AB. So they want to know what AB is. And BC is also unknown. But remember, we have two 45-degree angles here, which means the side lengths that are opposite the 45-degree angles are also the same. So we are going to do this problem, both methods again. We're going to do Pythagorean theorem first, and then the table. Okay, so if I'm doing Pythagorean theorem, I'm going to label my sides A, B, and C. And again, it doesn't matter which one's A, which one's B, so long as C is the hypotenuse, our formula is a squared plus b squared equals c squared. A is unknown, B is unknown, C is 30. And then we are going to do plugging into our formula. So we're going to have x squared plus x squared equals 30 squared. And then we're going to have 2x squared because we need to combine like terms equals 900 because 30 squared is 900. Divide both sides by 2 and we get x squared equals 450. And then we're going to take the square roots and we have x equals square root of 450, which we need to figure out most accurately. We're not doing decimals because if we look over here as our answer choices, they are in radical form. So we have 450 is 1 and 450, 2 and 225, 3 and 150, 5 and 90, 6 and 75. All right. We do already have a perfect square. But if we are not familiar with our perfect squares, we have to continue to factor all the way through until we can figure out what our perfect squares are. In this case, 225 is a perfect square. And I'm going to go ahead and stop there because it will take a while to factor 450, and none of you want to see me do that. So we're going to take our square root of 225 times the square root of 2, and 225 square root is 15, and square root of 2. So the answer is 15 square root of 2, which was D. Okay, so I'm going to go through and do it with the table now. And the reason I'm going to do it is to show you that it actually is a bit simpler. So when we're doing it with the table, we are going to label our side lengths A, root 2. So we're going to make our table 45, 45, 90, and it's going to be equal to A square root of 2. A is x, and A square root of 2 is 30. So if A equals x, I'm going to plug x in for the A that's for the hypotenuse. So we're going to get x square root of 2, and that is equal to 30. We're going to solve for x by dividing both sides by square root of 2, and that gives me x equals 30 over square root of 2. Now, we do not like radicals in our denominator, so we need to rationalize the denominator. We want it to stay the same number, but be in a different format, so that means we need to multiply by a version of 1. In this case, we want to get rid of the radical that's in the denominator, so we are going to multiply by square root of 2. Because when you multiply fractions, you're multiplying straight across, and square root of 2 times square root of 2 is simply 2. And then if we're multiplying the bottom by square root of 2, in order to keep the expression equivalent, we need to multiply the top by square root of 2 as well, because square root of 2 over square root of 2 is 1. So we get 30 square root of 2, but 30 is divisible by 2. So we get 30 divided by 2 is 15 times the square root of 2 is our answer for x. All right, so that's all the work for the practice problems for the week 3 for Pythagorean theorem and special right triangles. Remember, there is another special right triangle, the 30, 60, 90. Again, you can still use Pythagorean theorem for that, but it's not as easy if you think about it in the long run. Try and learn the shortcuts, but again, if the shortcuts don't work, that's fine. You can take the longer route. Sometimes when I'm driving anywhere, I will still take the longer route because it's the one I'm more comfortable with. So remember, math is like Google Maps. We all start at the same location, we all end at the same location, but we might take a different route along the way. As long as your route gets you to the end, it's perfectly fine. I'll talk to you guys later. Have a good day.